This is NSAA 2021, Section 1, Question 45. So in this question, we have 1 mole per decimeter cubed of hydrochloric acid slowly being added to an insulated flask containing 50 centimeters of sodium hydroxide. And we're told that the flask was gently swirled and the temperature was measured. So this is the graph of the changing temperature based on the amount of hydrochloric acid we added. And our question is to find which statement explains the shape of the graph. So let's go through our statements and see which one could be correct. So our first one is that the reaction has reached equilibrium. So is this the case? Well, let's think about the actual reaction itself, see if we can write an equation for the reaction. So we're adding an acid to our sodium hydroxide. That's going to neutralise it. So our reaction is going to look something like this. So our acid plus our hydroxide is going to equal our sodium chloride and water. And this equation isn't actually an equilibrium. And if we look here, the graph is still decreasing. It's not really reaching equilibrium. It's just run out of things to react with. It's just neutralised all that sodium hydroxide. So this is incorrect. Our second reason could be that an endothermic reaction is occurring after the X centimeters cubed of HCl has been added. So after this point, the reason our temperature is decreasing is because it's an endothermic reaction. Now, we've already kind of established that this is the point where all of the sodium hydroxide is used up. So the reaction stops. So there can't be an endothermic reaction happening because there is no reaction happening. So this question is also wrong. Our third statement is that the reaction rate decreases as the acid is used up. Now, could this be the case? Well, as we see, we are continually adding more and more acid. So it's not really going to be the acid that is being used up, but we only have a fixed amount of our sodium hydroxide. So that is the NaOH being used up, not the acid. So the acid reacts as soon as you add it, and that is going to use up all of the sodium hydroxide, not the acid itself. So this is also incorrect. Our fourth statement is that the sodium hydroxide has been neutralised by X centimeters cubed of the acid. So we can see X centimeters cubed is where the reaction stops. So there's no more reaction after this. And the NaOH is used up, and this is neutralisation. If we add an equal amount of acid and alkali, we're going to reach a neutral solution. So there's no more that can react. It must have neutralised it. So this is correct, and our final answer is D. But let's look at the last statement and see why that one's wrong too. So our final statement that we know is wrong is the sodium hydroxide becomes a weaker base as the total solution volume increases. So what is the definition of a weak base, first of all? So a weak base is something that doesn't completely dissolve to give its basic ions, the hydroxide ions there. And this doesn't change no matter the volume. It may have decreased in concentration, but it hasn't become weaker. The sodium hydroxide is a strong base. It completely dissolves into its ions. So therefore this question cannot be correct. And our final answer was D.